mathematics classes. Gurubhyo Namaha. In this video, I am going to solve some important questions of miscellaneous exercise from the chapter set theory. In this one, some numerical questions are given, some are theoretical questions. Now, I am going to focus on only theoretical questions. First, 1, 2 questions are numericals, so I am not solving them. I am solving third question. Let A, B and C are three sets. Such that A union B is equal to A union C, and number 2 it is given, and A intersection B is equal to A intersection C. Show that B is equal to C. Now in this question, 3 sets are there, A, B and C. There is some information or some properties are given about these A, B, C sets. And you have to show that B is equal to C. Now in set theory, to show that 2 sets are equal, you have to follow one rule. To show first set is equal to second set, you have to follow one rule. That rule is, you have to show that the first set is subset to second set, as well as second set is subset to first set. Then only you can come down to that first set is equal to second set. Then here you have to show that B is equal to C. So you have to show B is subset of C as well as C is subset of B. Again, how do you show one set is subset of other set? Very simple. If one X belongs to the first set, you have to show that X belongs to second set. These are the places. So, to show what is given solution. Given A union B is equal to A union C, and A intersection B is equal to A intersection C. We have to show that B is equal to C. To show that B is equal to C, we have to show that number 1, B is subset of C, and number 2, C is subset of B. Okay, first one I am going to show B is subset of C. I need to show B is subset of C. So what I do? Let X belongs to B. If you can show that my X also belongs to C, then I can conclude that B is subset of C. Now X belongs to B. Can I write this as X belongs to A union? Is it possible? When X belongs to B, A can be any set, but X belongs to their union. I will explain. Hi, this is A and this is B. If you observe carefully, my B is subset of this. My B is subset of this. Therefore, either x belongs to B or x belongs to A, then x belongs to A union B. So I can write whenever x belongs to B implies x belongs to A union B. Now, I use this condition. What is the condition? A union B is equal to A union C. It's one. So I can use that one. So this implies x belongs to A union C. X belongs to A union C. Now x belongs to A union C means here this implies x belongs to A or x belongs to B C. Either this or that. So my value x can be either A or x be C. So two cases I have. Now case 1, x belongs to C. Case 1, x belongs to C. It's obvious. I have taken x belongs to B and I have here x belongs to C. Therefore, x belongs to B implies x belongs to C. Whenever x is an element in B, it is also in C. Therefore, B is subset of C. Very good. Now, what is case 2? Case 2 is x belongs to A. X belongs to A. Case 1 is x belongs to C. Case 2 belongs to A. Okay. Now, x belongs to A. Can I write this as x belongs to A intersection B? Can I get this? Obviously, why? Because my x belongs to B. I have x belongs to A. X belongs to B as well as x belongs to B. A. Therefore, x belongs to A intersection B. Here, I use this condition. What is that? When x belongs to A intersection B implies x belongs to A intersection C. X belongs to A intersection C implies x belongs to A and x belongs to C. All I have x belongs to A, no problem. Now I have a new thing, x belongs to C. My conclusion here, I have sorted x belongs to B, ended with x belongs to C. Therefore, x belongs to B implies x belongs to C. This implies B subset of C. Similarly, we can prove C is subset of B. This is number 2 and this is number 1. From 1 and 2, 1 and 2, B is subset of C and C is subset of B. Therefore, B is equal to. Swagatam, Kapati mathematics classes. Gurubhyo Namaha. In this video, I am going to solve some important questions of miscellaneous exercise from the chapter set theory. In this one, some numerical questions are given, some are theoretical questions. Now, I am going to focus on only theoretical questions. First, 1, 2 questions are numericals, so I am not solving them. I am solving third question. Let A, B and C are three sets. Such that A union B is equal to A union C, and number 2 it is given, and A intersection B is equal to A intersection C. Show that B is equal to C. Now in this question, three sets are there, A, B and C. There is some information or some properties are given about these ABC sets, and you have to show that B is equal to C. Now in set theory, to show that two sets are equal, you have to follow one rule. To show first set is equal to second set, you have to follow one rule. That rule is, you have to show that the first set is subset to second set, as well as second set is subset to first set. Then only you can come to that first set is equal to second set. So here you have to show that B is equal to C. So you have to show B is subset of C, as well as C is subset of B. Again, how do you show one set is subset of other set? Very simple. If one X belongs to the first set, you have to show that X belongs to second set. These are the places. So, to show what is the solution? Given A union B is equal to A union C, and A intersection B is equal to A intersection C. We have to show that B is equal to C. To show that B is equal to C, we have to show that number 1, B is subset of C, and number 2, C is subset of B. Okay, first one I am going to show B is subset of C. I need to show B is subset of C. So what I do? Let X belongs to B. If you can show that my X also belongs to C, then I can conclude that B is subset of C. Now X belongs to B. Can I write this as X belongs to A union B? Is it possible? When X belongs to B, A can be any set, but X belongs to their union. I will explain. Hi, this is A and this is B. If you observe carefully, my B is subset of this. My B is subset of this. Therefore, either X belongs to B or X belongs to A, then X belongs to A union B. So I can write whenever X belongs to B implies X belongs to A union B. Now, I use this condition. What is the condition? A union B is equal to A union C. It's one. So I can use that one. So this implies This implies X belongs to A union C. X belongs to A union C. Now, X belongs to A union C means here this implies X belongs to A or X belongs to B, C. Either this or that. So, my value X can be either A or X be C. So, two cases I have. Now, case 1, X belongs to C. Case 1. Case 1. X belongs to C. It's obvious. I have taken X belongs to B and I have here X belongs to C. Therefore, X belongs to B implies X belongs to C. Whenever X is an element in B, it's also element in C. Therefore, B is subset of C. Very good. Now, what is case 2? Case 2 is X belongs to A. X belongs to A. Case 1 is X belongs to C. Case 2 belongs to A. Okay. Now, X belongs to A. Can I write this as X belongs to A intersection B? Can I take this? Obviously, why? Because my X belongs to B. I have X belongs to A. X belongs to B as well as X belongs to B. A. Therefore, X belongs to A intersection B. Here, I use this condition. What is that? When X belongs to A intersection B implies X belongs to A intersection C. X belongs to A intersection C implies X belongs to A and X belongs to C. All I have X belongs to A, no problem. Now I have a new thing, X belongs to C. My conclusion here, I have started with X belongs to B, ended with X belongs to C. Therefore, X belongs to B implies X belongs to C. This implies B subset of C. Similarly, we can prove C is subset of B. This is number 2 and this is number 1. From 1 and 2, 1 and 2, B is subset of C and C is subset of B. Therefore, B is equal to. Fourth question is, show that the following 4 conditions are equivalent. The question is, 4 conditions are given, you have to show that they are equivalent. So what is the meaning of this? The biconditional statements framed by 1 and 2, 1 and 3, 1 and 4 gives you same truth values. Now the concept of truth value you will learn in the 14th chapter, mathematical reasoning. So here what we need to prove, the biconditional statements generated from 1 to 2, 1 to 3 and 1 to 4 are equivalent with respect to truth values. This is actually what we need to prove. Now what actually is the problem is that A and B are two sets. A is subset of B. A is subset of B. This A is sitting inside B. Like this. This is A and this is B. If A is subset of B, then do you agree that A minus B is equal to pi? Yes. What is A minus B? The elements which belongs to A but not belongs to B. It's not the case. Therefore, A minus B, no element. So it is empty set. If A minus A is subset of B, then A union B is equal to B. Yes, it's also true. When A is subset of B, that means A is smaller than B. When you find union of these two sets, you will get superset. And this is also true. The next one is, when A is subset of B, A intersection B is equal to A. When A is subset of B, all the elements of A belongs to B. Therefore, the intersection of these two sets gives you smaller set. So when A is subset of B, A union B is superior set, A intersect B is a small set. And this is A minus B is equal to pi. You can do this by examples also. But you don't get any appreciation if you do example. We need to follow element-wise proof. Element-wise proof. So you can. What we need to do? We have to show number one, A is subset of B implies and implied by A minus B is equal to pi. Number two, A is subset of B implies and implied by A union B is equal to B. Number three, A is subset of B implies and implied by A intersection B is equal to A. Equivalent means these three biconditional statements are equivalent with respect to their truth values. Please try to understand, they are equivalent with respect to their truth values. So one by one we go. The first one, number one, we have to show that A is subset of B implies and implied by A minus B is equal to pi. It has two parts. The part one, A is subset of B implies A minus B is equal to pi. This is the first part. Second part, A minus B is equal to pi implies A is subset of two cases. First part and the second part. First part, given A is subset of B, we have to show A minus B is equal to pi. It's obvious it is, but we need to prove. But this is if possible. Let A minus B is not equal to pi. We have to show A minus B is equal to pi. It's obvious. But we have to show, for that we have taken A minus, let A minus B is not equal to pi. This is called contradictory method. Contradictory method. I'm following that. And A minus B is not equal to pi means, therefore, there exists and X belongs to A minus B. The symbol is there exists X belongs to A minus B. This implies X belongs to A and X does not belong to B. X belongs to A and X does not belong to B. What is the meaning of this? X is not a subset of B. Sorry, A is not a subset of B. But our assumption is A is subset of B. Our assumption is A subset of B. A subset of B, and we assume that A minus B is equal to pi. We assume that A minus B is not equal to pi. So we got a contradiction to our assumption A is less than B. Therefore, our assumption A minus B is not equal to pi is false. Therefore, A minus B is not equal to pi is false. Therefore, A minus B is true. B. A minus B is equal to pi is true. You have to show that A is subset of B. Okay. A minus B given A minus B is equal to pi. We have to show A is subset of X belongs to A. This implies X should belongs to B. Why this condition so? If X should not belong to B, then my X belongs to A minus B. X belongs to A minus B means X is not empty. It is a contradiction with our statement A minus B is equal to pi. It is true. Otherwise A minus B not equal to 1. Therefore, X belongs to A implies X belongs to B. Therefore, A is subset of B. So, let this is 1 and this is 2. Therefore, from 1 and 2, therefore, A is subset of B implies and implied by A minus B is equal to pi is true. A is subset of B implies and implied by A union B is equal to B. We have to go. So it also have two parts. Part 1. A is subset of B implies A union B is equal to B. Second one, A union B is equal to B implies A is subset of B. So we take one by one. Now, given A is subset of B, we have to show A union B is equal to B. How we can show two sets are equal in the set theory? We can show that two sets are equal only if first set is subset to second set and second set is subset to first set. Now here, because A is subset of B, we have to show number 1, B is subset of A union B. Number 2, A union B is subset of B. Now, I say the first one is obvious. Why? Because if you take A union B, A is subset of A union B as well as B is also subset of A union B. Therefore, B union B is subset of A union B is obvious. That's true. Now we have to show A union B is less than B, is subset of B. How do you show? If you take an element in A union B, you have to show that element in B also. So that X belongs to A union X belongs to A union B. This implies X belongs to A or X belongs to B. Since my A is subset of B, whatever element belongs to A, they also belongs to B. This implies I write X belongs to B. X belongs to A and B implies X belongs to B. Therefore, X belongs to A union B implies X belongs to B. Therefore, A union B is subset of B. Okay? Therefore, from 1 and 2, A union B is equal to first part over. Next one. A union B is equal to B, but I show that A is subset of B. A union B is equal to B is given. We have to show A is subset of. How you can show? If you take an element X in A, you have to show that the same element belongs to B. So let X belongs to A. I can write X belongs to A implies X belongs to A union B. Why? Because A is subset of A union B. A is subset of A union B. Therefore, if you take an element in A, it automatically belongs to A union any other set. Implies X belongs to, but A union B is given as B. So we got X belongs to A implies X belongs to B. X belongs to A implies X belongs to B. Therefore, A is subset of B. This is number 2. This is number 1. From 1 and 2. From 1 and 2. Therefore, our statement A is subset of B implies and implied by A union B is equal to B is also true. Next, third one. A is subset of B implied and implied by A intersection B is equal to A. Here also we have two parts. Number 1, A is subset of B implies A intersection B is equal to A. And second part is A intersection B is equal to A implies A is subset of B. Two cases. So case 1. Now A is subset of B is true. We have to show A intersection B is equal to A. Again, here you have to show two sets are equal. How do you show? You have to show that A intersection B is subset of A and A is subset of A intersection B. So here also we have two cases. Number 1, A is subset of A intersection B, and in case 2, A intersection B is subset of A. Again, A is subset of A intersection B is obvious. Why? Because my A is subset of B. When A is subset of B, my A is subset of A intersection B. The first one is obvious. First one, A intersection A is subset of A intersection B is obviously true. Obviously true. So come next one. To prove second one, let x belongs to A intersection B. When x belongs to A intersection B means x belongs to A and x belongs to B. X belongs to A and x belongs to B. Now it's given A is subset of B. This implies I can say that x belongs to A. So here x belongs to A intersection B implies x belongs to A. Therefore, A intersection B is subset of A. So first one is proved. Number one. Next, A intersection B is equal to A is true. A intersection B is equal to A is true. We have to show that A is subset of B. Okay, let x belongs to A. When x belongs to A, because A is equal to A intersection B, I can write x belongs to A intersection B. When x belongs to A intersection B, this implies x belongs to A and x belongs to B. Although we have x belongs to A, this implies x belongs to B. Therefore, for all x belongs to A implies x belongs to B. Therefore, A is subset of B. This implies A intersection B is equal to A, implies A is subset of B is true. Therefore this is number 2. Therefore, A is subset of B implies and implied by A intersection B is equal to A. It's true. Next question is fifth one. Show that if A is subset of B, then C minus B is also subset of C minus A for any set C. A is subset of B is given. We have to show that. Proof. A is subset of B is given. That means that is equal to, for all x belongs to A implies x belongs to B is given. We have to show C minus B is subset of C minus A. That means if you get an x in C minus B, it must belong to C minus A also. Now, let x belongs to C minus B. When x belongs to C minus B means my x belongs to C and my x does not belong to B. When x does not belong to B means this implies x belongs to C and x does not belong to B means x does not belong to A also. Why? Because A is subset of B. Why? Because A is subset of B. For example, look here. I have A here and this is B. X does not belong to B. It's not there. Right? It's not there. Therefore, it can't be in A also. Therefore, when x does not belong to B, because A is subset of B, x belongs to C and x does not belong to A. So, what is the meaning of this? This implies x belongs to C minus A. Therefore, for all x belongs to C minus B implies x belongs to C minus A. Therefore, C minus B is subset of C minus A. Fifth question, 4. Sixth question. A and B are two sets such that P of A is equal to P of B. P of A means power set of A. Set of all subsets of A, including A and I, is same as power set of B. That means set of all subsets of B, including pi and B. So here, power sets generated by A and B both are same. In that case, we can show that A is equal to B. Again, how you can show two sets are equal in set theory? You have shown that one set is subset of other set and other set is subset of the first set. Method is same. Okay. Now what is given? Proof. Proof. For two sets, A and B, P of A is equal to P of B. Is one. We have to show A is equal to B. For this, we have to show A is subset of B and B is subset of A. X belongs to A. Now, A belongs to P of A. Obvious. When A belongs to P of A, since P of A is given as P of A is given as P of B, this implies A belongs to P of B also. A belongs to P of B also. That means when X belongs to A and A belongs to P of B, therefore there exists an X, there exists one element C, there exists some C belongs to P of B, such that my X belongs to C. My X belongs to C. Therefore, my X must belong to B. Why? Because C is subset of B. Since C is subset of B, this implies my X belongs to B. Therefore, X belongs to A implies X belongs to B. Therefore, A is subset of B. Similarly, we can prove A is B is subset of A. Therefore,